Hello students, in this video we will be solving a paper from Senior Engineers High School, Montegiri. It is their first midterm paper which is given in December 2020 and for 20 marks. So our first question is question 1A, which says select and write the most appropriate alternative from those provided in the brackets and has got 1 mark. Let's see what is the problem. Okay, the question problem, according to the first problem, we have been given the coefficient of m0 is in the polynomial m square plus 2m cube minus 5m raised to 4 minus 7 is dash. The choices given to us are 1, 2, minus 5 and minus 7. Now first of all, in this we are asked only the coefficient of m0. Now what is a coefficient? Okay, coefficient in this entire thing, if we first of all we'll just rearrange this thing in increasing indices. So if we take minus 5m4 then 2m cube, so I'm just rearranging based on the powers, you no need for that, just m square minus 7. These are your powers or the index. Okay, this is your variable m which we have learned, and 5 is the coefficient, right? So in this 2m cube, if you have a look, m is the variable, 3 is the power or the index of that variable, and the number that comes before the variable is referred to as the coefficient. So in this case we are asked to find the coefficient of m0. If you have a look, we have m raised to 4, m raised to 3, m raised to 2. Okay, we do not have m raised to 1, and where is m0 then? Okay, now what is m0? First of all, m raised to 0, I mean anything, any variable raised to the power of 0 is always equal to 1. So in that case our minus 7 becomes the coefficient of that, because minus 7 can be written as minus 7 raised into m raised to 0. We know m raised to 0 is equal to 1. So it will become minus 7 into 1, which is nothing but minus 7. So that means the coefficient of m0 is minus 7. Okay, and it is not 1, as some will think that m raised to 0 we are asked. See, we are not asked for the value of m raised to 0, we are asked for the coefficient of m raised to 0. So m raised to 0 comes here and the coefficient is minus 7 as shown over here. So the answer to the first question for 1 mark is minus 7. So that is the answer to question 1A. Let's move to question 1B. Our next question, question 1B, says find 6 rational numbers between 3 upon 5 and 4 upon 5. So to answer a question like this, we can easily say 3 upon 5, we can multiply it by 10 upon 10, and 4 upon 5 can multiply it with 10 upon 10. In this way we get 30 upon 50, this will be equal to 30 upon, and this will be equal to 40 upon 50. Now which are the numbers? Now the denominators are the same, which are the numbers between? So we know that, okay, 30 is less than 31, which is less than 32, which is less than 33, which is less than 34, which is less than 35, which is less than 36, which is less than 37, which is less than 38, less than 39, and less than 40. Okay, these are the numbers between 30 and 40, considering that the denominator is the same. So we can easily say, therefore 6 rational numbers, numbers between 3 upon 5 and 4 upon 5 are, or maybe, well, the reason I'm using maybe is because you can choose, you have a liberty to choose any number from here right up till here, because we are asked for numbers between 30 and 40. Okay, all these numbers are, when we write it in this form, okay, let me choose some numbers. So 31 upon 50 comma 32 upon 50 comma 34 upon 50 comma 36 upon 50 comma 38 upon 50. We are asked for 6 rational numbers, 1 2 3 4 5 and 6. So if you see, I have not taken successive numbers, because we are not asked for successive numbers, we are just asked for 6 rational numbers between 3 upon 5 and 4 upon 5. If you actually go to divide in decimal form, you will also find that the numbers lie between 3 upon 5 and 4 upon 5. So these are 6 rational numbers. I could choose any 6 from this point to this point. So from 31 to 39, I could choose any number, but it should be in this fraction form, that is 31 upon 50, 32, because we are dealing with 3 upon 5 and 4 upon 5. Okay, so this is the answer, and this question has come for 2 marks. So 2 marks for this question, and with this we have got 2 marks. Let's move to the next question, which is question 1C. So question 1C says simplify, and it has got 3 marks. The first question, so it has got 2 problems under it, and we'll solve the first problem, which is 3 plus root 3 into 2 plus root 2. So to solve this, it's 3 into 2 plus root 2 with a plus sign in between, root 3 into 2 plus root 2. Next, 3 into 2 gives us 6, 3 into root 2 gives us 3 root 2, plus root 3 into 2 gives us 2 root 3, and root 3 into root 2 will give us square root 6. We won't be able to take anything common or add up, because it's a combination of rational and irrational numbers. So this is basically our answer. So our next problem is 7 raised to 2 upon 3 divided by 7 raised to 1 upon 5. In this case, the base is the same, and it is in this form: a raised to m upon n divided by a raised to p upon q. In this case, what happens is the base remains the same, and these two get subtracted. So m upon n will be subtracting p upon q. In fact, a similar problem is there in your textbook, however with the same powers, but it is a multiplication sign. So there is another problem with division similar, but to solve this, yes, this is the form. Basic form is this way: a raised to m upon a raised to n, which is a raised to m minus n. So we'll do the same over here, where the base is the same, and we'll subtract this fraction this way. So 7 raised to 2 upon 3 minus 1 upon 5, we have taken it common because the base is common to both of them. Now we need to remove the LCM for that. So here this will become 10 minus 3 whole thing upon 15, and this will be 7 raised to 7 upon 15. Okay, so that is your answer, 7 raised to 7 upon 15. Okay, with this we finish question 1C. Question 1D is, says attempt the following. It has got 4 marks and it has got 2 problems, so 2 marks for each. First question is factorize 2x square plus 7x plus 3. So for here you will need to split the middle term, 2x square plus 7x plus 3. Okay, this can be written as 2x square, and now it is 7x. So it is positive, the middle term is positive, the final term is also, the constant term is also positive. Okay, which means that the combination of both the terms will be positive. The combination of 2 terms, both of them will be positive. And if we have a look, 6 can be easily, we can easily get it as 6 into 1, which is 6, and if we add them, 6 plus 1, we get 7. So we'll write 6x plus 1x, or you can just leave it as a x plus 3, and now we take common between the two, we get 2x common, we are left with x plus 3, and here there is nothing to take common, so we put 1 and we are left with x plus 3 here as well. I take what is common next, which is x plus 3, and we write in the next bracket what is left, which is 2x plus 1, and that is these are our factors of 2x square plus 7x plus 3. The next problem is using identity solve 2x plus 1 whole cube. First thing is to identify the identity. If you have a look, this is actually a plus b whole cube identity, which is a cube plus b cube plus 3a square b plus 3ab square. So we'll use this identity 2x plus 1 whole cube. It can be a cube plus b cube plus 3a square b plus 3a right over here, 3ab square. 2x whole cube is 8x cube, then 1 whole cube is just 1, plus 2x whole square is 4x square. 4x square into 3 gives us 12x square, that is into 1, remains the same. And then you have 2x into 3, which gives us 6x. 6x into 1 whole square is also 6a. If we rearrange this thing in the decreasing power, so it is a of the variable 8x cube, you can write plus 12x square plus 6x plus 1. That is our answer. In fact, the same question is also there in the textbook. So with this, we have finished solving question 1 completely. Coming to the second question, we have select and write the most appropriate from the alternative provided below. The question is, a quadrilateral having two pairs of adjacent sides equal is called a dash, and the choices that are given are rectangle, trapezium, kite or parallelogram. To answer this question, we need to know what are these individual quadrilaterals. All of them are quadrilaterals over here, but they have different properties. Rectangle, if you see a rectangle, it would be something like this, where the adjacent sides, now adjacent sides mean the neighboring sides or the arms, okay, they should be equal, and there should be two pairs of that. Now here the opposite sides are equal in case of a rectangle, so we rule out a rectangle. What about a trapezium? A trapezium looks like this, okay, this is how a trapezium looks like, and clearly you can see that the adjacent sides need not be equal, okay, so we rule out trapezium as well. Kite looks something like this. Here the adjacent sides, two pairs of adjacent sides are equal, so this definitely falls in our category. What about a parallelogram? Okay, a parallelogram looks like this, where the adjacent sides are not equal, okay, so we rule them out. The opposite sides are equal, so our answer for this question is a quadrilateral having two pairs of adjacent sides is called as a kite. Okay, so that is for 1 mark. Moving on to the question 2b. Question 2b says lines L and M are parallel to each other and are cut by transversal N. Find the measures of the angles marked W, X, Y and Z. If we have a look at the figure given provided to us, we see 130 degrees is here. There are two parallel lines L and M, and N is the transversal. We need to find W, X, Z and Y. So the value of X has got to be equal to 130. Why? Because they are vertically opposite angles. Then W plus X equal to 180 degrees. How? It's linear pair axiom. W is what we need to find out. X is 130, we just found out, and that is equal to 180 degrees. That means W will be equal to 50 degrees. When we take 130 degrees on the other side of the equal to sign, it becomes negative. 180 degrees minus 130 degrees gives us 50 degrees. So now we have W is equal to 50 degrees and X is equal to 130 degrees. Now we can take X equal to, or angle X, you can put angles over here, all these are angles. Angle X equal to angle Z, and why is this? Because they are interior alternative angles. Why they are alternative? Because you know that L is parallel to M. Okay, so these are interior alternative. X parallel to Z, and if X is parallel to it, therefore you can say angle Z is equal to 130 degrees. Similarly, we can take angle W equal to angle Y. Why? Interior alternate angles. Again, L parallel to M. So this forms a Z if you have a look. See, and when they are Z, the angles that are formed in that Z, they are interior alternate angles and they are equal. So therefore, we can say angle Y equal to 50 degrees because W is 50 degrees. So this is how we get all the angles. This is 50 degrees, this is 130 degrees. 2 marks for this. Okay, so this is finished solving this. Question 2c is construct a triangle PQR in which PQ equal to 7 centimeters, angle P equal to 60 degrees and QR plus PR equal to 11 centimeters. Write the lengths of QR and PR. First we will draw a line, that is in order to mark PQ equal to 7 centimeters. So we won't draw it using a scale, but rather just draw a line, something like this. Okay, just a ray, and mark this over here. Let this be P over here. Now using a scale, I will see how much is 7 centimeters. Scale and a compass. I'll keep this on P. I'll keep the pointer on P. And I'll cut an arc. And that is 7 centimeters. So I'll mark this as Q. And this is 7 centimeters. Next, I look to draw 60 degrees, and that has to be from P because it says angle P equal to 60 degrees. So take just random measurement. I look to draw an arc this way. Now where the arc is cut on PQ, I will use that as a center with the same measurement that was used to cut this arc. I will draw another line this way. I'll draw another arc. Now make sure that this arc cuts this arc, because where the two arcs cut, that is where our 60 degree is forming. This is our 60 degrees. Okay, as simple as that. Mark this point. I'll draw a line through this point in such a way that it has to be greater than 11 centimeters, because next we'll be marking 11 centimeters on this particular line. If you want, you can mark this as a dotted line, or you can just draw a big line like this. And this will be your ray. Next, we measure 11 centimeters. So if you're having a problem measuring 11 centimeters because it's quite big, you can divide it into two parts. That is like how I'm doing, 5.5 and 5.5. I'll show you how to do it. So I'm just measuring 5.5 centimeters first. Okay, so I take it, use PA as my center, and I'll cut 5.5 here, and where this arc cuts this ray, I'll use that as a center and cut another 5.5 centimeters here. Now this till here is our 11 centimeters, and we will we'll join this point to Q in a dotted fashion this way. Here, right, and we'll just give some names over here. We'll give this ray A, and let this be B, and let this be R dash. Okay, because we're here to construct R, and for that, to get R, we'll have to draw a perpendicular to R dash Q. So to construct perpendicular to R dash Q, just measure. This is somewhere close to 10 centimeters. So what I'll do is I'll take 5.5 centimeters. Okay, that is more than half of the measurement of R dash Q. So to draw a perpendicular, we need to do that. Now that we have got that done, next job is to draw a perpendicular. So for that, I'll use R dash as my center, and I'll draw two arcs below R dash Q and above R dash Q like this, and then I'll use Q as my center with the same measurement. I'll draw two more arcs above and below R dash Q such that these two arcs cut. So now this arc is not cutting properly, so I'll use this R dash Q and I'll cut this arc this way. Okay, now if you notice, we have these two arcs cutting here, 1, 2. So to learn how to draw perpendicular bisectors, you may refer to the videos that we have done on construction for class 9. There you will find how to construct perpendiculars and other constructions with respect to constructing a triangle. Now next what we'll do is we will connect this line. We'll draw a line passing through these two intersections this way. Okay, and where this line intersects this PR dash, okay, that is over here, this will be our R, and we'll join RQ with a solid line, not a dotted line or a dashed line as you may call it. That is our triangle. Our next job as per the question is to find out the length of QR and PR. Remember, QR and PR together should be a total of 11 centimeters. That's when it is correct. So let us just check what is the measurement of PR and QR. So QR is somewhere around 6.3, and right there, and PR is 4. Let me have a look. Yeah, 4.7. So PR is 4.7 and QR is 6.3. The total, that is PR plus QR, is equal to 11 centimeters. These are centimeters. Okay. So this confirms that our triangle is correct. Okay, and this triangle is for how many marks? This triangle is for 3 marks. So with this we solve question 2C. Question 2D says ABCD is a quadrilateral in which AD is equal to BC and angle DAB is equal to angle CBA. Prove that triangle ABD is congruent to triangle BAC, BD is equal to AC, angle ABD is equal to BAC. Let us begin with what we have been given. We have been given this quadrilateral. We have been given AD is equal to BC. We have been given angle DAB is equal to angle CBA. The first thing we are asked to prove is triangle ABD. We need to prove this equal congruent to BAC. So let us begin with this solution first. So in triangle ABD and triangle BAC, okay, DAB, BAC. If we have a look at these two triangles, there is one common side to both of them. They have a common base, that is AB. We can take AB is equal to BA common side. Next, we have been given DAB is equal to CBA and they fall in different triangles. So DAB, angle DAB is equal to angle CBA. This is given. Right? What else? We have also been given AD is equal to BC. So AD is equal to BC, once again given, and these two sides fall in these two triangles TA and BC or CB. They are equal. So by side, angle side, we get the two triangles congruent. So therefore we can say triangle ABD is congruent to triangle BAC by SAS congruence rule. Now that we have got the two triangles congruent, if we have a look, we can take BD is equal to AC as CPCT. Okay, so BD equal to AC. And reason is CPCT. And we can also take angle ABD equal to angle BAC, CPCT once again. So full thing ABD equal to angle BAC as CPCT. And this has got 4 marks. So with this we prove this particular proof. Okay. And that completes our entire paper of the first midterm of that came in November-December 2020 for 20 marks. This is St. Anthony's High School, Monthigiri first midterm paper. Okay. So you see the questions that came in this paper were not at all difficult. It involved application of the concepts that we have learned in during our normal classes. For construction, if you would like to understand how things are constructed, different angles are constructed, and how we construct a triangle more in depth, you can refer to the videos that we have on construction for class 9. Okay. So I hope you have liked watching this video and you have been able to understand how to solve this video. We have completed solving this video within an hour. This is 1 hour paper, and you see, if you know the concepts, you can answer the paper well before an hour. Okay. Okay, so if you like the video, please click on the like button, share it with your friends and classmates who would like to know how to solve this paper. Please subscribe to the channel and do not forget to click on the bell icon to receive updates whenever a new video is posted. Thanks for watching. See you in the next video.